Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Nice, YouTube's working cool. Love it. All right, yeah, what's up? It is Tuesday.
That's dope.
I have 2 more lectures that I'm giving to my students at UCLA. One on Wednesday and then one on Friday, and then the final exam for them is on Monday. But man, I've been doing so much prep for them this week. I've been like creating so many things, like review guides, clicker question sections, like study this, study that, like I don't know. It's a lot of work. Yo, what up, Shantrix? What's crack-a-lackin', dude? Oh, and Zach. Yo, what's going on, Zach? Nice. Just started off, yeah. Dr. Juice. Is that Dr. Pickle Juice I see in the chat? What's up, Dr. Pickle Juice? Is that you, Pickle Juice? What did our announcement say? Today is Ed White became the first American to walk in space. Well, that's pretty cool. What? First American to walk in space. Who's this guy? I have AI actually come up with whatever our go live announcements are. I say like try to make something like sciencey or something. Let's look at who this Ed White guy is. I'm curious. Looks like an outstanding American citizen. Apparently the first dude to walk in space. That's pretty cool. That's got to be pretty wild, man. As I don't know, just as anybody on this earth, right? Where you're just like, I'm gonna go walk outside in the nothingness of the universe and hope it doesn't kill me. Is it true that Newton and Leibniz independently created calculus? Yes, they did actually. And there's some interesting like math like drama beef around that because of course Newton gets more of the credit for it, and I think Newton like claimed that Leibniz like stole it from him, but there's like no way they could have known because I mean there wasn't the internet, there wasn't ways to get ideas across very quickly, so must feel so special to be the first one to do anything, not gonna lie. Yeah, that's pretty cool. I mean, there are plenty of things that you can do for the first time, you know. You could be the first person to, I don't know. You could be the first person to be you. Right? It's funny. I had one of my old roommates, actually, yeah, this was actually kind of a funny thing that happened. One sec. What's up? Sup 1235556. Oh, I didn't save this photo, man. What? That's so dumb. Instagram, why don't you save my photos? When you think about it, you would be the first one to do something out of 100. Yeah, I mean, out of the total existence of the Earth, yeah. But also, like, new things are coming up every day, right? People in the past had no ability to even think about going into space, right? So it's only been the last probably like 10 or 20 billion people have even had like a remote chance, right, of getting into space. One way to think of it that way, right? One sec, where's my screenshots? Instagram. Where do they save all my stuff? Yeah, back this up, man. Let's get it. Ready to get academic. What's up, dude?
Oh yeah.
I can like barely I can barely even see your username because it's so dark and it's like a black background on this. Oh, what's up? Sensations here too. Anyways, no, my point I was trying to say is this last weekend I randomly, for whatever reason, ran into a lot of my old roommates that were with me during my first year of grad school. And one of them now has like a kid and is, you know, an announcer for like the Dodgers and stuff, all this crazy stuff. And we found it wild because he met his wife when he was out with us at some party. And my one other roommate ended up like going after her friend and then like whatever, they got together. And he thinks it's like such a wild thing. He's like, wow, dude, if we had never gone to that party, I would have never met this girl. I would have never married this girl. I would have never had kids. And like none of this shit would have happened. I'm like, that's kind of crazy. You know, it is what I think of like the butterfly effect. But to counter that, I always say that something had to happen. So, you know, if it wasn't that, maybe it would have been another party, another girl, another something else. But it is kind of crazy how these little individual moments end up changing the trajectory of things like very long term. But I always I have a little bit of pessimism there because I just say, well, something had to happen. You know, we had to go to some party. What's up, Sensation? There you are. Nice. Did you get a haircut, Sensation? Your hair looks nice. Was your mic working? New cut. Well, that's like he's got to get his stuff working.
I always wear a hat.
He always wears a hat. I always wear a hat too. I got my hat. Yeah. But yeah, nice. Jeff says, I mean, if you say 100 random words, you technically be the first person to say those specific words in that order. Exactly. Right? Yeah, that's exactly what I say. Ooh, I have a new feature, Sensation. You might like this on the vertical, where anytime someone says something in the Twitch chat, it replaces the bottom image with, instead of it saying like, hey, submit your screenshots, it replaces it with the chat. So like, I don't know, I did some cool little coding with it's called Sammy. Sammy is a way to trigger OBS things from other stuff. We won't find our wives donating to OnlyFans. Why? Oh, I see. You won't find your wife by donating to OnlyFans. Probably not. Yeah. I mean, there's 100% chance of something happening, I guess. Like, there's always a non-zero probability. But probably not the most healthy of relationships, yeah. That's for another day. I could go on forever ranting about OnlyFans and what it's done to society, but... anyways, let's see. Yeah, today's Tuesday. If you haven't already, we do have the geometry tournament, the geometry challenge with our friend Nick from Wibbly. That's going to be due tomorrow, so make sure if you haven't done it yet, go do it. It's in the announcements. Otherwise, I don't have anything super special. I've just been prepping a ton for this final exam that I'm teaching for my UCLA class, so... Dr. Gold reminding about homework. Yeah, there is homework. But the homework, they get gift cards for the homework. So it's not really homework. You know, it's more like, hey man, you want to make some money? Very easy. Dude, what's up? What do you got for me, Sensation?
Can you play this? Okay, not that.
Teaching a 45-year-old brain rot? Persons of interest.
Can you play this in a small screen?
I mean, I can play it over here, I guess.
To try and like get around the
in the college setting,
get around the what?
DMCA.
Oh, I don't really care. Whatever. They might get mad at us. What is this? Is this... Ooh, he's showing pi. That's cool.
Pi. Can any of you tell me what it means?
Can't really hear it. Oh.
Oh, you can't really hear it, yeah?
I'll settle for an intelligent question here.
Oh, whoa, is this from Lost? Is this
No.
this is the guy from Lost? No, isn't it? One second, let me turn this volume down. What is the use of
My
this
friend
anyway?
has a question, Mr. Swift. What is any of this good for, and when would we ever use it?
Oh my god, this is always the question any teacher gets all the time, yeah.
Let me show you. Pi. The ratio of the circumference of a circle to its diameter.
Pi
This
is a super
is
trip.
the beginning. It keeps on going.
It goes on forever and ever.
Without
Forever and
ever
ever.
repeating. Which means that contained within this string of decimals is every single other number. Your birth date, combination.
Oh, that's a cool idea.
Social
Yes.
security number. It's all in there somewhere.
Because
And
it's
if you
infinite.
convert these decimals into letters, you would have every word that ever existed in every possible combination.
Dun dun
First
dun.
syllable you spoke as a baby, the name of your latest crush, your entire life story from beginning to end, everything we ever say or do, all of the world's
Is
infinite
encompassed in
possibilities
pi.
rest within this one simple circle. Now, what you do with that information, what it's good for,
What show is this? It's called Persons of
well,
Interest.
that would be up to you.
Is that what the show's called? Person of Interest? That's pretty cool. I like that. Yeah. I like to say that pi is evidence that we live in the Matrix. You know, that everything's like a simulation. Yeah. Do you think that's sensation?
Person of Interest. It's a great show. You should see it.
Oh, okay. I will see it. But yeah, he is right in that, yeah, if you have like a circle, and you have a diameter, right, which is like this. And this is like a basic thing that's seen in everyday life, right? We see circles all the fucking time, you know? The sun's a circle. Well, approximately a circle. That, yeah, the ratio of the circumference, which would be like this distance around, over the diameter, so C divided by this, is equal to this mystery number pi. Which, yeah, I only know up to this. I know 3.145926. That's all I know. But it keeps going on forever and ever and ever and ever and ever and ever. Yeah. So is E for that matter, yes. Zach is right. Yeah, and that's where Zach gets his name from, E to the 2i pi, right? Because he is forever and infinite. Now that we got some users here, I'll shout you out, Zach. 14159. Yeah, sorry, my bad. Yes, good. Good save. Wait, does non-repeating automatically mean that every possible pattern is achieved? 19526. Okay, see, even I have them like kind of wrong. There was something in the news recently about pi. I think like someone computed like 100 trillion digits of it or something.
It is 3.14159.
Oh, it is 3.14159? Okay, wait. All right, whatever.
It has to be.
15926. Okay, it's something like this. Oh, you're good. You're good. Okay. You could write an irrational number in base 10 and just with just ones and twos, and it wouldn't include every possible pattern. Yeah. Here's the 1 million digits. Okay, let's go check out the 1 million digits of pi. Oh wow. Yeah, it's a kind of a cool it's a concept, right? By something being infinite, it means it has no end. So it means that yes, eventually at some point in this sequence, there has to be the possibility of your entire life story being written out in numbers that eventually go out into letters. Like, it has to happen eventually, but it's like forever. I think it's cool because some very basic things in the world, right, relating how far it takes to go around a circle with what's the furthest distance from one end of the circle to the other, we cannot explain with our current number system. Like, we as humans have not come up with an adequate way to describe such a basic thing in our lives. So I think that's cool. I think that's super
Do you know
wicked.
do you know why you can't?
Why you can't? Why
Because
can't you?
numbers are absolute.
Okay.
analogs are not absolute.
Sure. So
Ever.
you're talking about like digital and analog, kind of like they talk about like a circle, right, can be approximated as an n-sided shape, right? Where you just like start increasing the number of sides. Like if you wanted to approximate a circle like really badly, you could just approximate it as a square, right? You know, this is a pretty bad approximation.
We went through this.
Yeah.
Where it's like a circle has either no sides or an infinite amount of sides.
It has an infinite number of sides, right? Because then you could start doing this. You could create, an octagon, right? An octagon gets closer. And then you can go up and up and up and up. And I think that's kind of the infinite thing, right? Where there is no absolute. There is no set number of sides that will describe a circle. Yeah. What's up, Abzo? Yeah, pi's wicked.
Assume the cow is spherical.
Yeah, assume the cow is spherical. That's a physics joke. So in physics, we tend to approximate a lot of things as, in order to make the math and the numbers easier, we make kind of brute approximations. So for instance, if we're doing wind resistance or we're doing, I don't know, moment of inertia or something, we'll just say that everything's like a circle. So the spherical cow is the big joke you see. Spherical cow. Yeah, they do this all the time in physics. It's
What did that say?
This one said reality physics moo. Or wait, this one. Let's see what this one says. Frictionless spherical cow with no air resistance. Right, exactly. Assume a cow uniform density while ignoring the effects of gravity in a vacuum. He's like, can't breathe. Yes, so bad. It's like, what are we doing to these poor cows? It's all in the name of science.
Oh yeah, because Schrodinger's cat is so much less cruel.
Yeah, well, that one's is either alive or dead, right? Yeah. Wait. Oh, this is cool. TPMC has. Oh, this is very cool. Oh, dude. Oh, this is wicked. This is a Desmos simulation where you can increase the number of sides. Sides. Is that what we're saying here? Whoa, dude. We're going to the infinite. That is wicked cool. Yeah, hail Satan. Yeah, at some point. Yeah. Very cool.
It kind of looks like a.
It kind of looks like a pentagram at some point. Yeah, right. It's cool. Like it almost it like aliases periodically to look like a square at times. You see, like we get very simple shapes, and then like not, and then very simple, then not, then very simple, then not. I think that's something to do with like pi over 2 or something. Bam, 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 bam. Wow, this is super cool. Very cool. I like that. That's fun. Yeah, but that's a way to like try to approximate a circle. Oh, fractional sides. Oh, that's what it talks about. Oh, whole numbers are regular polygons. Okay. Oh, okay. I see. Yeah. So pi is cool. We went over a bit of that yesterday, right? What about?
So it's just, Doctor G said hi. Doctor G said hi.
Yeah, Dr. G said hi. Dr. G is always saying hi. I
Stop
appreciate
saying
all the
hello.
highs.
We know you're here.
I think it's because there's some button on their YouTube shorts where they just click it and like it says hi. I think that's how it works. Yeah.
Listen, caveman, stop mashing buttons. Right?
Well, if they mash buttons, we still get engagement. So.
Ugh, we mash buttons. Ugh.
Yes. Yes,
Fucking
me.
Sort your head out.
What's up, Swift Strike? Swift Strike said hi, lol. Okay. All right. I think we got some good questions for today, so we're going to go out and help you guys out with some math and science, learn some stuff, and start you guys off. All right, here we go. Let's start the stream. Welcome, everyone. Office Hours. My name is Dr. Cole, Sexual Education, stream that helps you out with math and science homework. All sorts of fun stuff today. We were just going over pi. Twitch is cool. We don't need no buttons. Yeah. That button doesn't appear for me at all. I've never seen that. Yeah. It's a YouTube thing, I think. Pretty sure what it is. Tomato sauce.
This is probably the worst possible time to bring. This is probably the worst time to bring this up, but we really do need to talk about Kick actually.
About Kick? Yeah. Do we want to start streaming on Kick at some point?
The top 10 are all moving over now, so
that's hilarious. But let me ask the viewers here, and mainly the viewers that are high school students. Do you guys even know what Kick is? Like, do you even watch Kick? Kick to me was like the place to go watch like alt-right, YouTube people that got banned off of YouTube, right? Shantrick says Kick is a hellhole. Shantrick says Kick is a hellhole. Uh-oh. Maybe they need Jesus, and Jesus, I mean math. we could spread
math
the gospel
Jesus.
of math to these people, right? Would that be what we do? I don't use it because I heard about gambling and stuff, and I don't want to get involved with that. Yeah, I guess that's how they. Yeah, again, it's like the underground of the internet, but I don't know.
The only gambling you need to take part in is £100 on zero.
wait,
You ever played
in
roulette?
fucking roulette?
Yeah. Hey, I've won that bet before.
Yeah. Wait, Swift Strike says he's an 8th grader. I've heard of it and have watched it once or twice. Okay, so they do go there sometimes, I guess. I don't know if I want to condone people going to Kick though, because it's not really regulated very much, which is good and bad.
0 or 00. 00 is an American thing, so no.
No, not Kick. No, Kick.com, KIK.com. That's a different website. That's like a chat thing. I'm pretty sure, right? He's talking about like Kick, like the actual like how you spell out Kick, which I think is similar to Rumble. Is that the same one as well?
I've heard of Rumble, but I've never seen it. So
I've heard of Rumble. That's where like people who are banned on YouTube go over there. We're not banned on YouTube yet, so don't necessarily have to go there. But yeah, Rumble, right? You've heard of Rumble as well. Yeah. I don't know. I mean, I guess we might be unique over there because we'd be the only people like actually giving out useful, truthful knowledge versus, I don't know, thinking that Bill Gates is infecting our blood with like, microchips. So I don't know. Might be useful.
that's
Kick
one. Have you ever seen some of the stuff on the science and technology category on Twitch?
Oh, are they crazy sometimes? They put the tinfoil hat on?
You ever actually prove some of it? It's like fucking the best of flat Earth and stuff like that.
Oh man, flat Earth. Oh Jesus. Yeah, we don't need to go there. Okay, here, let's try to do this question. A bag contains 3 red marbles, 6 blue marbles. Akshan, okay. Removes 1 marble at a time until the bag is empty. Each marble they remove is chosen randomly from the remaining marbles. Okay. Given that the first marble that Akshan removes is red, and the third marble they remove is blue, what is the probability that the last 2 marbles are both blue? Wow, okay. So I think we have to build like a probability tree here. Not the probability problems.
You gotta get in the hospital now.
Yeah,
And
we're gonna
I
enjoy some
said,
pain.
Just shut up and let me enjoy this pain.
Unless
Yeah,
it's
we're-
making some bullshit that takes like 45 minutes to solve.
No, this is question 7, which means it's not that bad. Question 7 shouldn't be that bad. We should be able to do this. This is like a delta math problem. Yeah, I think this is a math challenge question, is what it is, which is cool. I mean, I appreciate these. I used to hate these, like vehemently, and then I started getting good at them, and now I don't hate them anymore. Because I always learn something from them. And at the end of the day, I can always just ask Shantrix like what the answer is, and then I learn from the answer. So I think for myself, it's been a personal journey in accepting things that I don't know or understand and like learning from them, which I think is a valuable thing these days. So there are 9 choose 3 possible paths. Well, let's get there. So I like drawing the pictures first. I'm a little slow, but okay. So what happens is I remove 1 marble at a time. Okay. And the first one I remove is a red marble, right? Okay. So now I have 1 less red marble, right? And then and the third marble they remove is blue. Wow, so we only say about the first and the third. So this is like something happens, right? So this is like beginning. And this is like question mark. We don't know what's going on here. But oh, so you know what? This is actually kind of cool. We can kind of we can build out. I'm gonna build out like a tree path here. Watch what we're gonna do. I'm gonna say that there are 2 options here, right? I could remove a red. I could remove another red, which that would come here, right? Or I could have removed a blue. Dr. Juice and Swift Strike said hi. I appreciate the highs. Thank you guys. Okay. But then this is kind of like, okay, but then we know what happens, right? Because then we remove the third marble we remove is blue for sure. Okay. So now we have this. So the third marble we remove is blue. Okay, cool. Oh, except this has 1 less red one in it, right? Wait, actually, gotta be careful here. Gotta copy the right thing. Okay, now we remove the blue one. Okay, cool. And then the last 2 marbles are both blue. So wait, how many more marbles do I have to remove? I have to remove, I think, 4 marbles, right? I have to remove 4 marbles. My button hasn't reappeared. What's your button? What's the button he talks about? Okay. So then you have to do 4 more removals. And then there have to be 2 blue left, right? Yeah, okay, cool. I think I can get this. So there's a total of 1, 2, 3, 4, 5, 6. Okay. So there's so it's out of 6, right? Jeff, is that how we do this, right? I can say like there's 6 marbles left. In this case, I have to pull out 3 blue and 1 red. R question mark B. Yes. Question mark, question mark, question mark, BB. Yeah, but I think I just need to get to here, right? Because then I'm guaranteed to pick out... oh, wait a minute. No, you're right. Wait. Yeah, no. I just need to get to the last 2 ones being blue, right? I just need to get to this point, I think. Yes, exactly. Yeah. I agree. Yeah. So here I would have to pick out 3 blue and 1 red. Here I would have to pick out 2 red and 1 blue, right? Or, sorry, 2 red and 2 blue. Yeah. That's what has to happen, right? So I can call this like a success, right? Let's call this like, this is binomial, right? And then this is going to be a failure. Or, well, I did the wrong colors with these. 1 second, sorry. Here. You have to consider the possibility that the last 2 aren't blue. The last 2 have to be blue, though, right? Yeah, if you want to see it in horizontal form, go to that link down there, which is actualdiscord.com/submit, and then there should be a view on Twitch link for you if you want to see. Right, so I'm going to find... Wait, he's saying find the probability that they are blue. Maybe. I think I want to do this. Let me see. I might be wrong, but let's see. So the probability of this is 2/6. So this is a probability of 1/3. And then this is a probability of also 1/3, right? Here, this is a probability of 1/2. Wait, no, sorry. Probability of 1/6. What's up, Swift? What's up? NY Gamers. And then this is a probability of 1/2. Given the first and third are red. Yeah, okay, let's see. I think I got this. So, oh, but this is not binomial now. Was there something wrong with YouTube? I think YouTube's okay. We're doing all right. He just wanted to see, I think he wanted to see a better format. You want to see the horizontal format because YouTube is vertical.
Good luck.
Yeah. Yeah, there you go. Probability always like kind of boggles my mind. Cause yeah, it's not binomial, is it? Well, wait a minute. Yeah, no. I got it. No. I think I got it. Let's just do this. This is what, yeah, I think I got it. Okay, here we go. This is what it is. This is a success. Because picking the other blues is still okay. Yeah. Got it. Okay, Jeff, I'll try that in a second. I want to see if this works. I think this is just the probability of 6 choose 2. I think this is binomial, so I think this is going to be 6 choose 2. Yeah, I know I don't have to think about it. I just want to try to think about it sequentially because that's like logically what makes sense in my mind. I like to draw the pictures and be sequential. And then, yes, I go back and there's a cute little probability trick where, like, I don't know, you consider like buckets and birds or some shit. And then it just makes sense. I want to see if this way works as well, though. Yeah. Yeah, again, you guys are talking about, yeah, all the different like manipulations you can do. Yeah, it's cool. Okay. So this is going to be 1/3, and I need exactly 2 successes here, and then I need 2/3 to the 4th. Okay, that's the probability of this. And then this is going to be 6 choose 1. And that's going to be 1/6, not 1/3. Sucks I was late when this question is very up my alley. Well, it's still here. If you and Jeff want to collude on a way that works, I'll probably eventually like just end up doing it your way because this will probably break. 6 choose 1, this to the 6th, and then it's 5/6 to the 5th. Okay, let me get probabilities for this. That's the next thing I need to add on the YouTube stream is the calculator. I do need to do that. I will figure that out at some point. Okay.
Nice.
So, I think I can do. I think there's like a stats button here. It's like 6, and then it's like probability or something. What the fuck is that? Oh, I think it's under like math. Probability. There we go. Yeah. 6 choose 2. I'm gonna say times 1/3. Do this if you have free time. Okay. Times that. Times 2/3 to the 4th equals that. And then I wonder if I can convert this to a fraction real quick. Okay, cool. So this is 80 over 243. Okay. And then this one is 6 choose 1, which is just 6. And then times 1 over 6, which to the 1 is easy. And then this one's... Oh, right, okay, duh. But then it's times... 5 over 6 to the 5th. And then let's math convert that to a fraction. That's a very ugly number. But sure. 3125 over 776. Yes, I do. I have a PhD in physics. Thank you, Sensation, for telling that. Or do you just like math? I don't have a degree in math. Yeah, I have a degree in physics though. Mechanics for pre-meds, 5A. Okay, cool. So that's probably this. That's probably this. And then I feel like... Okay. We have to figure out what the probability is for this split happening. So if you were to pull a blue, right? Or here, to pull a red, you would need... That's a 2 out of what? 1, 2, 3, 4, 5, 6, 7, 8. So this is a 1/4 chance. And this is a 3/4 chance. Okay, cool. So I think I do 3/4 times this probability. And then I'm going to say plus 1/4 times this probability. So I think it's this. So let's do it. Let's say this times 3/4. Then we're going to do this times 1/4. Almost as good. I love the shade. Okay. I think, I mean, this looks ugly. Chandrix, do we have an answer to that? You're attempting to get 100 in Algebra 1? Oh, nice, dude. Well, if you want some practice with it and you got like a screenshot of a question you want to go through, NY Gamers, I'll do it here on the stream with you. And maybe, you know, we have people that can like chime in and say like faster ways to do it. Okay, so this basically equals like 0.1. And then let me do this thing times 3/4. That equals like 0.2469. So if I combine those, I get 0.3469 as my answer. Zone Ranger says 10 out of 21. The answer should be a little less than 0.5. Okay, so my method didn't work. Oopsies.
You gotta get in the hospital now.
I'm enjoying this pain.
I just said, just shut up and let me enjoy this pain.
So Saint says it's 7 choose 2 divided by 5 choose 2. I love when fucking stats or probability is just like, yeah, it's just this choose this over this choose this. Like, okay, but where the fuck do you get that? Okay, here he says, out of the 9 marbles, when I have access to actual.education, because actualdiscord.com is an easier thing to type in. If I say actual.education, no one knows what that, like they do actual.education.com or something, so like I just make it easy. Chandrick says it's the other way around. He says it's 5 choose 2 over 7 choose 2. All right, let's see. Yeah, exactly. Yeah, if you do this question with like pure combinatorics, which is like the elite way to do probability, it is cool. I wish I was better at it. I think you assume the chance of picking red is fixed, but it changes depending on what you picked before. Oh. You're right. You're so... Wait. Because, wait, Jeff. This thing here, I think, something about, like, replacement. Does the binomial theorem, like, assume replace... Yeah, this assumes independent trials, which is wrong. Right? Because whatever happens in one picking affects the next picking. Actual Discord seems like actual Discord. Like, actual itself. Like, Discord itself. Well, maybe that makes this look legit then. Yeah. Technically, it's unsolvable because they said marbles are chosen randomly, but they gave no distribution. Right. Okay, Jeff. Okay, so yeah. So this is why I was wrong here, is because this assumes replacement, which is not true. Because, yeah, the probability of picking something changes. Although I feel like... Yeah, you're right. We did the January 2012 Regents for a practice, and I got a 90 on it without studying. Nice, dude. The Regents exam, like, just determines whether you can go to, like, super fancy high school, right? In New York. Is that how it works, the Regents exam? All right, let me see what they say. Okay. All right. Each possible order in which Akshan removes marbles. Right. Since we were told the first marble red and the third is blue, we would like to consider the sequences of this form. Okay. 7... Okay, this is where it's combinatorics. Yeah, they draw these cute little pictures like this. 7 blanks must be filled with the remaining 2 R's and 5 B's. So there are 7 choose 2 ways of doing this because 2 of the blanks must be chosen in which to place the R's. Okay, because there's only 2 reds. Yes. However, you can't put the reds here. Right? Is that what we say? Right? So I'm not allowed to put the reds in these 2. And I think that's where the 5 choose 2 comes in. Because 2 of the blanks must be chosen in which to place 7 choose 2. Yeah, you're right. You're right. Yeah. What's up, Raven? Dude, I haven't seen you in a while. What's up, Raven? Good to see you, Raven.
Konbanwa.
Is that what's the Japanese? Does that say like hello or something?
It says konbanwa, good evening.
Oh, good evening. Yeah. After you place 1 red and 1 blue, you have 2 reds and 5 blues left. I agree with that. So you have 7, and you have to pick 2 of them. Well, you have 7 places, and you have to pick 2 places to put the reds. But of these 21 ways, some have the ways of the 2 marbles being blue, and that is of these sequences. Okay, so in these sequences, 5 of them must be placed with the remaining 2 reds and 3 blues. Since there are 5 choose 2 10 ways to do this, because 2 of the 5 blanks must be chosen in a place to place the reds. Therefore, 10 of the possible 21 sequences could end in 2 BBs. Okay. Okay, so this is the total way to place 2 of the reds anywhere. And then you want to say, okay, but how many ways can I place the 2 reds and I'm safe to assume that there are 2 blues here? That's clever. That's 5 choose 2. So then it's just 10 over 21. Wow, that's super cool. Very cool question, Shantrix. I appreciate that. Yeah, combinatorics is beautiful when you can get it to work. And it is usually something where you're thinking about the negative space. Or what do you call that? Like the complementary space, I guess. So instead of deciding like what's the probability of the blues being there, you're like, what's the probability of the reds not being there? Right. You have to realize that the number of ways to place the reds is the same as the number of possible sequences. Yeah. Yeah, it's kind of a tricky one. But combinatorics are always really cool. So, yes, my way of doing this was wrong. Because, and I was correct here, at least writing different probabilities with the not doing replacement. But once I got here, I need to do this. This needed to be done without replacement, which I have to think how I would do that. I think that's more combinatorics. I think we do like. I think we. So yeah. Okay. Wait. If I wanted to do this right, I think this would be like 6 choose 4, right? That's the total ways to place all of them, right? So I would say 6 choose 4 is on the bottom, and then to only choose 2 of them to be red, that would be 6 choose 2. Wouldn't that be right? And then here, this would be 6 choose 1 over 6 choose 4. Let me see if that comes out to be the same thing. I'm actually curious. What is it? 6. See, now that I start thinking in like combinatorics language, now it starts making sense. It's one of these things where it's been so long since I've done it, so I have to like refresh my brain on it. And then what's 6 choose 2? Oh well. Oh, 6 choose 2 is the same thing as 6 choose 4. Uh-oh. that doesn't work. Well, wait a minute. Wait. 6 choose 4. And then I think it's 4 choose 2. 4 choose 2. So I think it's just always 2. It's also 2. So is this like 6 over 15? And then this is 4 over 15? And does that add up to be the same thing? So this times 3/4. This times 1/4. So I get 1 over 15 here. You could create a Markov chain. I don't want to choose violence today, dude. So that's 1 over 5. So 6 over 20 plus 1 over 15. Wow, thanks, Sam. What's up, Sam? What was the answer again? It was 10 over 21. So that's 18 over 60 plus 4 over 60, which would give me 22 over... Yeah, not right. That would not add up to the answer, so this is also wrong. Oh, man. Okay. My knowledge of combinatorics is not okay. Okay, I like... Yeah, this stuff is always a mindfuck for me. It's kind of cool, though. I got to get better at it, but appreciate it. Okay. Cool question, Chantrix.
Why is it frozen?
What's frozen? Are you frozen? Oh, your webcam's frozen. Why is that? Sensation, you're frozen, dude.
It's not me because it's working in front of me.
Oh, okay. Well, it's not you, it's me. I'm gonna turn it back on. Always gotta keep your brain running like keeping a furnace running. Yeah, it really is. It still looks frozen on my end. Oh, no, now you're good. Now you're good. Now you're good. The math is the coal.
Strange.
What's up, Mizan? Someone else had a pretty good question here. Someone asked a physics question. I like physics questions. I mean, don't get me wrong. I like all the math combinatoric stuff too, but this was a fun one. So someone said that 2 stones are thrown vertically up simultaneously with different velocities. Which of the following graphs represents the relative separation between them as a function of time? Ooh, okay. So let's say we have like stone 1. And then let's say we have stone 2. And, you know, is this Suvat time? Yeah, Suvat, yeah. We don't use Suvat in the US. Yeah, he's talking about this. Like S is equal to. I think it's. Wait, what do you use U for initial velocity? Is that what you guys do? Do you say like UT plus 1/2 AT squared? Can we call the stones Keith and Mick? Why do you want to call them Keith and Mick? I mean, sure. Yeah, this is
one's
Keith.
English and one's Irish. I don't know.
This one's Keith. Yeah, isn't Mick like a derogatory term for like Irish people?
It was.
It was.
But it's still an actual name.
Oh, it is. Yeah, I mean, yeah, I have a friend named Mick. For me, I use V0. It can't be 1 or 4 though. Okay, well, we'll see. Let's see. Well, it's okay. Key thing here, guys. It's represents the separation between them. Okay, so let's write out what that would be. Okay, so the position. We're gonna use this equation, which is that x is equal to x0 plus v0 t plus 1/2 AT squared. And then I'm just going to call x in the y direction. So whatever, fine. Let's change it to y so it doesn't confuse people. Y is equal to y0 plus v0 t plus 1/2 AT squared. Okay, so if we were to write this out for stone 1, like the position, right? We would say like y1 is equal to, let's say things start at 0. You sent me one? Did you put it in help screenshots? Where'd you send it to me, NY Gamers? I don't see it on the web thing yet. If not, another way you can do it, because here this is where I see like the screenshots coming in. So these are from yesterday. I haven't seen anything here. So did you use the website actualdiscord.com/submit? Maybe the bot's down, but I don't know. It was working earlier. Wait, I can always test this. 1 second. Let me test it 1 second. So if we go here and I say my name is Bob, and I'm gonna upload a file. Let me just see. Let me do something real quick. I'm gonna go upload. Oh no! See, that comes in. That comes in for me. See, it's right here. Bob has submitted a screenshot. Maybe try it again. Try it again. Try submitting again. It should work. But okay. So y1, we're gonna say this each thing starts at 0, and so we're gonna call this like v1 t. Yeah, Roblox. We were playing Roblox this weekend, and then I'm gonna say this is minus 4.9 t squared because the acceleration due to gravity is negative 4.9. Now for stone 2, okay, that's going to be that y2 is equal to v2 t minus 4.9 t squared. Okay, and let's say, for instance, that v1 is greater than v2. So let's say that this one is the faster one. Let's say this one's Keith. Keith is fast. Okay. Thank you, Sensation. I will drink. Okay, so if we want the separation between the two, right? The separation. Well, watch. So the separation between the two would be y1 minus y2. Which, if we were to do that, let's say we did this. Let's say we just came over here and we just subtracted these two formulas, right? So this would get me that y1 minus y2, these would cancel, is equal to v1t minus v2t. So that's equal to v1 minus v2t. Okay, so here's something you should notice here. Is that, yeah, the positions of them are parabolas, correct? But the parabolic term, the t squared here, goes away. So, in fact, the separation is linear, right? Because you see as time goes up, the separation between them goes up, as long as v1 is greater than v2. So, that tells me it can't be 3 and 4. It can't be 3 and 2. Can't be this one, can't be this one. Now, let's look at the difference between this, because this seems to suggest that something weird is happening here. And what do we think that could be? So, if we consider the paths of these things, right? Yes, I will explain why the sign changes. It's actually really cool why the sign changes. So let's say this is time, for instance, and then like let's say this is like position height, right? So the fast one is going to go up something like this, whereas the slow one, right, is going to go up something like this. The slow one, Mick here, Mick is slow, will hit the ground before the green one does. So there will be some certain time here where the red one is... So between here, like while they're both in the air, the distance between the two is increasing linearly, right? And then eventually what happens is the red one hits the ground and no longer moves. And so now the green one actually closes the distance in between the two. And you can see it's going to do that faster and faster and faster because this thing is moving down faster and faster. So, because this is not linear, right? As time goes on, the distance of this ball from the ground where the red one is... Oh, you just sent it in Discord instead? Okay, cool. All right, I see that, yeah. It is technically incorrect after a certain time, which is after the time that the red ball Mick has hit the ground. So I believe it's actually this one. It's answer 4. Because it's not linear, right? So actually, we can do this on Desmos. If you want to see how we do it on Desmos, it's pretty cool. I did this earlier today. So this is a Desmos simulation of it. So here we have the green one, right, and the red one. And these are the equations of... Yay, Desmos, right? Yeah, okay, so here, let's turn these off. Sorry. So the green here, right, this is what we could say is like the fast one, right? And then this red one is like the slow one. You can move the slider around. And we can pick... we can then have another graph here that subtracts the distance from the two, right? So that's me doing the BT minus 9.8 t squared minus the AT minus 9.8 t squared. And yes, you can do restrictions on Desmos as well. So do you see here I have a restriction? So if I know the red one hits the ground at 0.5, I manually put this in. I don't know if you can have functions for the restrictions. That would be cool if you could. But I put that as 0.5. That shows what the difference is up to there. And then this thing here will show what the difference in the distance is past that 0.5 until the green one hits the ground. Oh, you can? Interesting. So I think the way to do that would to say that's the square root of... sorry, I gotta remember math, how that works, sorry. So if you have... One sec. Oh, but it's a quadratic though, isn't it, right? So you have 0 is equal to V0 minus 4.9 t squared. T, right? You can cancel out one of the t's. Oh, so you get... It's this. It's V0 over 2g. Right? Square root. Square root of V0 over 2g. No. No, not 2g. Sorry, over 2v0 over g. That's what I want to say. Yeah. Spaces are not required. Oh, okay. Well, let's see if we can do that. So, I wonder if I can do that. So, that would be square root of 2 slider a over g, right? Let's see if we can do that. Here, I wonder if I can do this. Square root of 2a over 9.8. Yeah. I don't know if it reads that though. Right? So that'd be, oh, that's from 0 to 1. Oh, wait, I have something wrong here. One sec. My physics is wrong. So I have G over 2 T is equal to V naught. So yeah. Oh, the square root is gone. So it's T is 2 V naught over G. No, there's not a square root here. My bad. There we go. That should be it, right? No. One shark. No, it's... Let me get rid of this. It's GT over V naught. No. T is equal to 2 V naught over G. 2A over G. What's up, 1K? Oh, I need this to be 2 times B, not A. I'm dumb. No, 2A.
Nice.
Why does it stop there, though? Interesting. Is it just A over G? Is that what it is?
Welcome in, Supper Crotch.
What's the math trying to count for? I'm trying to count for the amount of time it takes for the small one to hit the ground. Which, I'm pretty sure I had that right. If you have something leaving up at a velocity v naught, you just have 0 is equal to 0 plus v naught t minus 1/2, and then that's going to be gt squared. So then I cancel out the t's, and I just say 1/2 gt is equal to v naught. So then t is equal to 2 v naught over g. Velocity and time, no, right? Yeah, exactly. So why is that not coming out correctly here? It should be 2 v naught over g. Should be that. But that's not the amount of time it takes for this one, for the red one apparently, to hit the ground. What? Oh, you know why I fucked up? Here we go. That's why I fucked up. My equations didn't have the... Yeah, this is where we fucked up. Okay, there we go. Now it's going to work. It's going to work now. Watch this. I forgot to divide g by 2. That makes me so sad. There we go. There we go. This is the full thing I want. Yes. Yes. And then this is going to be from 2a over 9.8 all the way out to 2b over 9.8. Very cool. There we go. Now we have a fully working Desmos thing, but let me adjust my little viewport here. Yeah, there we go. That is so cool. Is there a setting for me to like see things like... Yeah, there we go. That's what I want. Yeah, there we go. Good. There we go. Very cool. Okay, this is very cool. This is wicked, dude. I'm sharing this. One sec. Where do I go to share? Save a copy? Share. There we go. Share this graph. Yeah, then here, let me delete this. Let me put this here. Anyways, cool. That's a cool question. And I didn't know you could do this with Desmos with the coding. This is very cool that you can move this around and it'll only graph certain parts. Like, watch this. So depending on like what the velocity is for each things, we can make the full graph of this. This assumes that both lines are under the same gravitational conditions as y it's going to 0. Yeah. What if they're launched at different times? Yeah, that would screw things up. Let's not do that, Jeff. No choosing violence. This is cool. You can like you can change the graph based on the initial velocities. I think that's really wicked. All right, let me see. I got a question from Strike though. Let's do strikes real quick. Okay.
Oh no.
This one was cool though. I really like this one.
I think we do paradoxes.
What are paradoxes? What are the paradoxes you want to do, Sensation? What's that? What's the paradox?
I don't know, the twin paradox. Let's start with that one.
God, that one is a mess. Paradoxes aren't meant to be explained.
Oh no.
The Cretan's paradox? I think they solved that one.
What about Occam's razor, dude? I always love I love that we use the word razor for things in like logic and philosophy. Paradoxes are conceptual, not actual. You're very there are true words there, Sapper Crutch. Welcome to our stream, by the way.
Actually, that's not true of the Cretan's paradox, because that was an actual thing.
Oh, okay. Well, then it can't be a paradox. It's real. Okay, let's talk about strike. So he said factor the expression completely. Okay, cool. When I see things like this, we could use u equals x squared. Yeah, Jeff is very correct. So there are a couple ways to do this. I'll show both ways. So one way is to recognize anytime you have some pattern of like something's to like, I don't know, like the 8th and to the 4th and to the 0th, right? Which is really just x squared, x to the 1st, x to the 0. And this is just like a number. This is a quadratic, which we know how to do quadratics pretty well. Yes. What do I say again? Salam alaikum. Was that what Sensation? What do we say? What do we say to the Arabic people? Salam alaikum. Alaikum. I don't know.
Salam alaikum.
Salam alaikum. God damn it. Salam alaikum. There we go. Okay. So yeah, one way to do this is to say, let u equal x squared. There we go. Al salamu alaikum. Okay. So then u squared is equal to x to the 4th.
Regional differences as well.
Yeah. Arabic goes all over the place depending whether you're in like Egypt or like Saudi Arabia or something, right?
Anyway,
so
the response to that is alaikum assalam.
Alaikum salam. Okay. There we go. This is an easy thing to factor, right? Because now I just say Assalamu alaikum. This is our greeting in Islam. Very cool. So, yeah, here I can say like, okay, what things multiply to -7 and add up to 6? Well, that's pretty easy. Just +7 and -1, right? And so now my solution is u what is it? U plus 7, u minus 1. That's how we factored this. Okay. But that was in terms of u. So in reality, I now need to replace the u with the x squareds. So what I get now is I get y is equal to x squared plus 7. Yes, very good. Yeah, exactly. X squared plus 7, and then this would be x squared minus 1. Now this is something special here. Anyone know what that is? X squared minus 1? That's a cool thing. Difference of squares. Exactly, dude. Yes. So we can rewrite this as x plus 1, x minus 1. And now this is going to be x squared plus 7, x plus 1, x minus 1. And this thing, I think you're done. Right? Isn't that right? I think that's all we have at that point. You can't factor this because this is going to be imaginary. Because you need x squared equal minus 7. Yeah. Oh, 5 is 1 plus square root of 5 over 2? Really, this? Yeah, we're just going to keep it there. Yeah. So that's one way to do it. That's a really cool way. The other way you could have done this is, so this is like the easy way. You could also do it the hard way. So what I can do is I could like try to find factors. We could say like, or find zeros. And usually if you're finding zeros, a great one to test is just test like x equals 1. Yes, exactly, the rational root theorem. Yeah. And when you do this, right, you get 1 to the 4th plus 6 times 1 squared minus 7 equals 0. So that's a check. So now what you have to do is do polynomial division. This is useful when things don't look really nice and like a quadratic here. It's good to know how to do this. So now what I'm going to do is I'm going to divide x minus 1 out from my x to the 4th plus 6x squared minus 7. And actually, I think I have to put all the ones in between, right? So we have to say plus 0x to the 3rd plus 6x squared and then plus 0x minus 7. And so then x minus 1 goes into x to the 4th. That goes in x to the 3rd times. So you get x to the 4th minus x to the 3rd. So then these cancel out. You get 0. And you get, this is just going to be x to the 3rd. Which then like, all right, cool. X minus 1 goes into x to the 3rd. X squared times. So now you get x to the 3rd minus x squared. And here, let's like bring this down. So then that's going to be 7x squared. So then that's going to go in 7x times. And that's going to be 7x squared minus 7x. And then here, bring the minus 7 down as well. And x minus 1 goes into 7x minus 7. That just goes in negative 7 times. I think this is hard and takes way too much time. It does, but it's good to know this process. So then, so we have minus 7x minus 7. And then, yeah, that becomes minus 7x plus 7. Wait a minute. We want a remainder here for sure. I want these to cancel. Something's wrong. What's wrong? You can put the 7 on the right hand side and then complete the square. That's another way to do it. You are right. That is another cool way to do it. Sorry, I just want to see why this is wrong. X third. 7x squared, cool. That goes in 7x times, so it's 7x squared minus 7x. Oh, this is plus 7x, that's why. This is plus 7x, so this is plus 7. Good, okay, now we're good. Now we're good. Okay, I was getting a little worried there. And then this is plus. Or this is still minus. And this is minus 7. Okay, cool. So that's a 0. Yes, good. All right. So then you get, okay, cool. So this is a mess, right? This then gets you x minus 1 and then x to the 3rd plus x squared plus 7x plus 7. And then I think at this point, can't you just group this by factoring almost? Yeah, I feel like I could group this, right? Now I could like take this and this and say this is the same thing as x times x squared plus 7. And then this and this is plus 1 times x squared plus 7. Yeah, right? Yeah, nice. This is actually really cool. And now you get to factor out this and this. And so then this would become x plus 1. And then this stuff becomes x squared plus 7. And then this becomes also x minus 1. Which is the same answer.
My man!
Yeah, math is cool. Again, so this is another way to do it, right? That way it kind of sucks. This way is pretty easy. Let's show... what if the zeros are not obvious to start with? Yeah, if the zeros are not obvious... So I always say, like, just start out testing 1. Like, test 1 and minus 1. Maybe plus 2 and minus 2. If those don't work, then this is not the method to go with. Cybercloud says, shouldn't it only have one way to do it by orders of operation? Well, I mean, orders of operation... I mean, there's many ways to skin a cat here, you know? Right, 2 doesn't divide by 7, exactly. Well, I check plus 1 and minus 1 first, because those are the easiest ones. And if those work, then
Good job!
you can keep going. If they don't work, go check plus 2 and minus 2, and then at that point just stop. That's what I say. The other way you could have done this, and let's just show it just for completeness, is that, yeah, you could have done completing the square. Which... Let me see if that works. So I think what you do is you take this and you divide by 2 and you square it, and then you add it to both sides. So that becomes 3x squared. So no, that becomes 3. Okay, so we're going to add 3x squared and we're going to subtract 3x squared, I think is what we do. So let's see. So you have x to the 4th plus 3x squared minus 3x squared minus 7. Is that does completing the square work when it's like this, or can I only do that when it's a quadratic? Like here I can complete the square. That's easy to do. Can you do that here? I don't think you can actually. No, right? Oh, wait. I think I remember what you have to do. Sorry. You don't add 3x squared. You add 3. Right? I think you add 3 and you minus 3. Or you add 3 squared and you subtract minus 3 squared. Yeah, okay, watch. So this is x to the 4th plus 6x squared plus 3 squared, and then it's minus 3 squared minus 7. Is that what we do here? This is goofy. And then I think... Well, this isn't going to work then, because then this isn't x plus 3... Is this x squared plus 3 squared? Minus 9 minus 7. So minus 16. Does that work? Sorry, am I doing something wrong here? That's not really factored though. That's pretty trash. Right? That's not... Yeah. This doesn't look good at all. What? Yeah, I guess that works. It's just weird. Yeah, so completing the square is like not a good idea. Don't do that. Yeah, don't do it. Don't do it. It means x squared plus 3 is equal to plus or minus 4. Okay, x squared plus 3 equals 4. Yeah. Okay, so x squared is equal to 7. Or x squared is equal to... Or x squared plus 3 is equal to negative 4. So you say x squared is equal to... Sorry. No. 1. This one is negative 7. Got it. Okay, cool. So this is where you can say x squared minus 1 is equal to 0. So you have x squared minus 1 as a factor. And then here you have x squared plus 7 is equal to 0. So that means x squared plus 7 is a factor Oh, okay, I see. And then you get x minus 1, x plus 1, x squared plus 7. Wow, that's cool. Okay. That's one way to do it. I don't like this though. I don't like this completing the square stuff. This is bad. This is the easiest way to do it. In the case that you can't immediately recognize a quadratic there, NY Gamer, then this is kind of like the brute force way to do it, which is you use polynomial division, which if you haven't seen before, it's very powerful. It's a very cool thing. You can use this to break down big polynomials. Actually, I have a YouTube video on this one. If I go to my YouTube, let's go to my channel real quick. Just for people, if you found us, we do a lot of like tutorials in math and science stuff. So if I do polynomial, I think it's called factoring. I think the video is factoring. Yeah. Here we go. This is the video. How to factor really big polynomials. Yeah. So this video I have right here was just x. 2, 3. This uses the rational root theorem, and I show you how you do. This is synthetic division, is what it is. Synthetic is like cooler and it's faster for this type of stuff. But I'll dump this in the chat for you guys if you want to see it. It is pretty cool. Where's my live streaming chat? There we go. Can I chat, please? There we go. Yeah. You can use synthetic. You can totally use synthetic division as well. Yeah, synthetic is totally legal as well. I just find that polynomial with synthetic, you got to be careful, right? Because if I were to do this with synthetic division, this doesn't become an x minus 1, right? This just becomes a 1. And then these, you have to make sure you write out all these numbers. So what that's gonna be like 1 0 6 0 minus 7. But yeah, so you pull this down. That's 1. 1 times 1 is 1, so that's that. So then this is 1. 1 times 1 is that. So then this is 7. 7 times 1 is that. 7. That's 7, and then 7 times 1 is 7, and then that's 0. You do get the same thing. You do get this is the same thing. You get x to the third plus x to the second plus 7x plus 7. This is actually a lot faster than doing this, right? Do we see how quick that was to do synthetic division? But yeah, watch that link there. That YouTube video will show you like how to do this synthetic division compared to this. This is cool though. I don't know. It's because to me, like, students already know long division from like their algebra classes, and so if you just show them that, hey, you can do long division as well with like polynomials, it kind of clicks. The synthetic thing is a trick. I remember there's some fun proof for like why it works, but in any case, I hope that helped you there, Strike. What I'll do here is I'll save this for you. And then I'll put it in our math form. I'm liking to do this thing here. So I'm gonna create a post. I'm gonna say like strike. And then here I'll put this in. Nope, I don't need this. Let me put this image in. And I'm gonna tag this as math. Yeah, so now we have a little thread here, so I'll put your guys' questions in here so you can see them later. Polynomial division is not real. It can't hurt me. Whatever you need to say to keep you, help you sleep at night, dude. Also, for earlier, I made this, which is helpful to learn. Let's see, TPMC, what'd you make? This is very cool, but what the hell is this? Excuse me? Dude, what am I looking at here? Is this me staring into the depths of my soul, dude? This is cool with true false though. Look at this. Yeah, I see on the sidebar. You got like some messages here. Is this like a manifesto? Oh, this is how you can nest conditions, I guess. Okay. Syntax lookup table-ish. Yeah. It's a cool way to see like how that works, and then like to see what the graph works. That's cool. Okay, we got another fun little statistics question from Saint. Let's check it out. Saint, you're gonna have to teach me about combinatorics. What's up, Justin? You wanna come up and say hi? Let me give a coin here to Strike. Good job. Strike, you get a coin for asking a question on our server. Oh, it glitched? Okay, cool. Tell me when it fixes. Here, let me see if I can get this in a more friendly thing.
Oh, there we go.
What's up? What's up, Justin? What's crack-a-lackin' doing?
What's up? What's up? Nothing much.
It's the first day of summer for you, right? First day of summer?
It's been the first day of summer for the past 5 days. I'm joking. Nah, but the first day was summer for me was the 29th or the 30th. The 30th.
Oh, nice. You had to take a final exam though the other day. I remember. Yeah.
Oh yeah, I absolutely crushed that shit. I also crushed the entire year.
Nice, dude. That's always the best because
I should get a bond coin, okay?
Yeah. Well, show me your grades. I'll give it. You get bond coins for posting good grades. You know how it works.
Yeah, but here's the thing. I don't got the email that my mom got for my fucking grades. I'm kind of mad.
What? Well, tell your mom you want a screenshot of your grades. Yeah. I love ChatGPT CyberClutch. I'm a big fan of it.
Oh my gosh, have you seen the AI studio with Google?
Yeah, VO3.
No, like you can just like open up a complete AI studio. It has every model they have.
Oh, okay. Oh, I know
It's
what you're
called
talking
AI
about.
studio. Google something.
Yeah, they've been really making some headway. I mean, they had a rough start for sure. Like their first AI
Gemini
stuff.
was terrible at the start.
Yeah, it was terrible. Google Gemini was like fucking trash. But they've gotten really good now, especially since their new video generation stuff is training itself on all of their fucking YouTube content, which is like,
what?
Bro, they have so much video content to train on. It's nuts.
That's a little too much.
Yeah, it's gotten really good. Like their video generation is scary good. It's expensive, but like it's cool.
I'm scared for myself.
Yeah, they're gonna start doing all the deepfakes, dude.
Oh my god. I seen a governor or something like a state have deepfakes and she found them within like 5
Oh
minutes.
yeah, and she brought them into like the Senate hearing or something.
Yeah,
She's
she
like,
brought them into the courtroom.
yeah, she's like, yo, these are deepfake nudes of myself, and I was like, excuse me, like, don't do that.
But they're like, it's easy to get a deepfake within 5 minutes with the Google search filter off.
Yeah, I'm sure it is. Yeah. I mean,
is
that's
very
like what Rule 34 was back in our day. You know, you can make weird pictures of anything if you really want to.
Bro. Well, my song, you haven't been to my office hours in forever. So.
Well, I'm glad you're here, dude. Yeah, good to see you. Good to say hi, dude. We're gonna play Fortnite this weekend if you wanna play with us. So go get it downloaded. Yeah, so go get it downloaded.
I already have it downloaded on both.
Good.
I have GeForce Now Ultimate, so now I can like cloud stream it, and I can what is it? And I can play it on my Xbox. Well, not my Xbox.
Hell yeah. Yeah. Nice, dude. Yeah, we'll play. I like the Star Wars stuff.
I'm not a big fan of it, but I'll say fuck it.
Yeah, it's dope. Whatever. I'm a huge Star Wars.
No,
I'm a
we can't
huge
play-
Star Wars nerd.
Saturday, there's a live event on Fortnite.
I was gonna play on Sunday. Can we play on Sunday?
Sunday's gonna be a whole brand new season.
Okay, we'll play the whole brand new season. It'll be dope, right?
Wait, hold on. Let me double check.
Yeah, go check it for me. So Cybercrutch says, do you only do math or do you dabble in physics too? I do a lot of physics, bro. My PhD's in physics, so I teach a lot of physics. We were doing some physics. This was yesterday. Someone was asking about E&M. We did some E&M physics here. And then I was even doing, this was transistors. Someone was doing like a circuit question yesterday with me. We did some Mensa IQ questions here. We did some Facebook soccer mom math. This was very interesting. Markov chain or infinite series here. Yeah, those words scare me, guys. Markov chain. I have no clue what that means. Okay, let's look at this. Both 1, 2, and 3, 4, 5, 6 give you your roll in cash, but 1 and 2 let you roll again. Oh. Sorry. Okay. Got you. Okay. So, on a roll of 1 or 2, you receive the amount of dollars of your roll and roll again. Okay. We don't use Markov chains. Yeah, no, I never really saw that in any of my undergraduate or graduate career. I didn't see Markov chains. I see why it's an infinite series though, right? Because as long as you keep hitting a 1 or a 2, you get to keep running, right? Right? So if I think about expectation value, so given we're playing $5, right? So here my expectation value, right, is going to equal to the probability times the amount. So that's going to be equal to 1/6 times 3 plus 1/6 times 4. If I draw the arrow back to the square, okay. Plus 1/6 times 5 plus 1/6 times 6, right? Or 1/6 times, yes, yes, you could take the average of these things, right? You could say 1/6 of like low plus high all over 2. You're correct. You could do like the expectation of the average. Yeah, that works too. Okay. Okay. 4 times, yeah, okay. Yes. I'm just gonna do it this way, just because. Yeah, you could do it as 1/6 of 3 plus 4 plus 5 plus 6, right? So that's 7, 12, 18. So it's equal to $3. Is that your expectation value? Seems kind of weird. I guess it makes sense though, because you only have a 4 out of 6 chance of this happening, right? We do that right? 7, 12, 18, or 6. Yeah, okay, cool. So, you're going to make $3 here. The question is, will the amount here get you like an extra $2? Right? Because here's what you have. It's actually really interesting. So, in the simplest case, right, you have the expectation value is equal to 1/6 times 1 plus 1/6 times 2. This is in the case that you don't get to roll again, right? So this would be equal to 1/2. But if you hit this, you technically get to do it again, right? But, oh, I think I see how this works. So is this plus 1/3 times the probability of 1/2 plus 1/3 times 1/3 times 1/2? Is that how this is going to work? Oh, very cool. So let's think about this. So if you hit a 1 or a 2, right, there's a 1 out of 6 chance of hitting a 1 and 1 out of 6 chance of hitting a 2. That's how much you would make if the game ended. Thanks, NY Gamers. Yeah, good luck on your stuff. Oh, NY Gamers, if you ever want to know whenever we're streaming, we have a whole calendar for that. It's here, calendar.actual.education. So this will tell you when we're streaming. I'm actually not streaming tomorrow because I usually stream on Wednesdays, but I have to go to a town hall for our department because we have no money. Fancy that. UCLA has no cash. So we won't stream tomorrow, but I might put some extra streams on Thursday and Friday. In any case, this calendar always gets the most up-to-date with our schedule. So anyway, sorry. It's not like students are not paying enough tuition. It's more like the money is getting mishandled. And like probably going to a bunch of fucking dumb admin positions or like fake jobs for people. Yeah. It's probably where all the money's going. But we'll find out. Because the tuition's plenty high. So if the game ended, then you would expect to get $50 from this. However, because this happened, you get to go again, right? But the chance that you get to go again means that you had to hit a 1 or a 2. And the probability of a 1 or a 2 is equal to 2/6, which is equal to 1/3. So now your expectation value is the probability that you hit this, which is 1 out of 3, plus an extra $50. And then to play like a third time, well, now you had to do that twice. So, yeah, so this is really cool. Oh, is our YouTube chat up to date? Is it up to date? I hope it is.
I think so.
Yeah. Oh, well, actually, no.
Some dumbass comment was just like, use calculator.
No, I mean, there might be a cool little... There's a hack to those sometimes. Where is... One sec. Let me make sure my chat's working on that one. Because it can be weird.
Right. There could very well be hacks to that. There are lots of mathematical hacks. But when someone's first comment is, what is the square root of 87,000?
It's like, do a barrel roll. Do a barrel roll.
Yeah. Dance for me, monkey, dance. No, use a fucking calculator.
87899, you say. Okay. So, this is an infinite series, though, right? Is that what you guys mean by, like, Markov chain? So, this would be equal to the summation from n equals 0 to infinity of 1/2 times 1/3 to the n, right? So this is equal to 1/2 summation n equals 0 to infinity of 1/3 to the n. And I believe this is a geometric series, right? Which I want to say is equal to 1/2 over 1 minus 1/3. Is that what this is? I remember the sum is equal to like a naught over 1 minus r. If you have like a naught r to the n. Also, yes. Wow, I'm on fire today.
That's dope.
Okay, so then this is 1/2 divided by 2/3, which is the same thing as 1/2 times 3 over 2, right? So that's equal to 3/4. Interesting. So you're only gonna make 3/4 of a buck here. That's really shitty. So yeah, okay. So this would be equal to 3/4. Oh shit, Jeff. Oh wait, whoa. I forgot about that. Yes, but on each one, you're right. Okay, because when this happens, so first of all, you would get the 1/2 plus 1/3 times this, but you would also get this maybe happening. But if you hit this, then the game ends. Right? Do you see what I'm saying? So, do I just add a 3 at the very end of this? I see. So whenever this ends, you get $3. But eventually you will. Okay. So I think we say this is equal to... That's cool. This is 3/4 plus 3. So then, yeah, right? I would totally play this game again. Because this would be 6 3/4. Right? What's up, Equity? Did I do this the right way, Saint? Is that correct? Oh, no. Uh-oh. Is it because... Sorry, it's 1/3 times 1/2. Oh, I get it. And then it's plus 1/3 times... Right, you start with only 3. Okay, here's my question. Is it 1/3 times 1/2? And then this is plus... I gotta think about this. So it's that or that. But provided you hit it, it's this. And then this is 1/3 times 3. Or 2/3 times 3. Yes, thank you, sorry. And so then this is plus 1/3 times 1/3 times 1/2. And then this is going to be 1/3 times 2/3 times 3. I think I'm starting to see a pattern here. Okay, so I think I see this. Right, because it's 1/3 times now the 2/3 times 3. This is like some n-1 bullshit. Yeah. Okay. So then this would be the sum from let me see, n equals 0 to infinity. And then I think it's 1/3 times 2/3 times 3 to the n. Oh, okay. Oh, so that's another 3/4, right? So that's gonna be 9/4? Right? Wait. So this is going to cancel out to become 2. This is going to become 3/4. So that's going to become 6/4. So then you get 3 halves. So it's 3 halves plus 3/4 plus 3. It's 1/3 n times 1/2. Yeah, okay, cool. So that's 4.5 plus 0.75. Yeah, good. Is equal to 5.25. Wow. Yeah, just barely. I would just barely play this game because I had to pay $5. And I only make 5.25. Yeah, I see that. Okay. Oh, that's very clever, Saint. I like that. That's a very clever way to do it. Probability's pretty dope. Because there's like so many different ways to do it. Nice. This was Saint's solution to it. But I think it's really cool. For everyone else to see. And then Equity, what's up? You in the chat, Equity? You want to go over your chemistry after this? I'll do it. Yeah, since I'm 1 and 2, you start over. This is cool. I like this way of doing this one too. Yeah. Nice. Cool. Good question there, Saint. I liked it. It's cool.
Good job.
Good corn Saint. Ooh, what munchies you got for me? Sensation, what do you got? You got some munchies for me, dog? What's up? You holding out on me? McCoy's. Ooh, salt and vinegar. The grab bag. Nice. They're not called pork rinds over there. What are they called? Cracklings? Cracklings?
Pork. Crackling is from the roast. Pork scratchings.
Scratchings. That's right. They call them scratchings. We'll look at them. Saint says, that's the kind of stuff they ask you in the math econ interviews, which is why I've been prepping it. Oh, wow. Yeah, he's talking about, like, during interviews for certain positions, they do ask you, like, these teaser questions just to see if your brain knows how to, like, solve things in certain ways. It's actually quite cool.
Well, I'd fail.
Me too, probably. I need the help of all you guys on the stream here to figure stuff out. And ChatGPT.
Me like hammer. This is the kind of answers I give.
Give me hammer. Let me see if Equity's around. Good for you for prepping it, though. Okay, it says a commercial refrigeration unit accidentally releases 12.5 liters of ammonium gas. Determine the mass and the number of molecules released. I think, isn't this at STP like 22.4 liters is equal to like 1 mole? Isn't that right, Equity? Wagwan, dude. I just forget if ammonium is like is an ideal gas. I guess we assume it has to be an ideal gas, right? So I think you do 12.5 over 22.4 to get like the number of moles. That's my calculator. Is it 22.4 by the way, or is it 22.1? Moles, gas, liters. It is 22.4. Okay, cool. And then yes, the Avogadro's number. So we do 12.5 divided by 22.4. That gets me 0.558 moles, which then we're going to multiply by 6.02 times 10 to the 23 over 1 mole. And so that's going to get us a lot. 3.56. Or 3.36, sorry. Times 10 to the 23 molecules. And then for mass, you see the mass of ammonia. Is ammonia NH3 or NH4? Ammonium is NH4. You're right. Okay. 17 grams per mole approximately. Okay. So then I just 17 grams per mole. So what? That's gonna be about like 8.5 grams. Yeah. So we can say well 9.49. Nice. Not too bad. What's the difference between NH3 and NH4? So, ammonia is NH3, which is usually a gas. Ammonium, which is NH4, I believe is usually a liquid. I think ammonium is usually a liquid. You can ask about this. Like. Or maybe not. Well, wait, so ammonium NH4 plus is actually a polyatomic ion, which I think usually bonds with other things. I don't think you have NH4 plus in the wild. I think NH4 plus usually bonds with other things. So in the case of ammonium hydroxide, it bonds with OH. I had a calculator just like that one in high school and programmed Avogadro's number into the L. Felt like a hacker doing it. Yeah, dude, I used to code like super fun games on the TI-84. Yeah. So I think ammonium equity is usually an ion that bonds with other things. So ammonia is NH3, and this is stable by itself. And then NH4 plus is ammonium. And this usually, so this is like stable. And I think this usually like bonds with things. Because it doesn't like being plus. It's not a very positive thing. I wonder if I should have a Python program that calculates the determinant inverse of a matrix. I don't seem to have that function in my calculator. Really? I think the TI-84 does do inverses and determinants. I'm pretty sure it does. Yo, what's up, Phobos? What's up, Phobos? Good to see you, dude. We're doing some chemistry right now. Oh, you use a Casio. The TI-84, yeah, TI-84 definitely does matrices. If you go here to second matrix, you can make matrices here. So here we could do like, let's say like a 3x3. And let's just make it like 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if you want to do math on that, you go second matrix math. And then yeah, here you can do the determinant of that matrix. It'll do it. Okay, that determinant is 0 apparently. That's cool. Yeah. We were stuck solving substitution methods for solving ODEs. Wow. That sounds a lot scarier than the math I'm doing here, which is simple log operations. ODEs, that's nuts, dude. Yeah, no, the TI-84 is dope. You can use it to solve systems of equations if you just put them in a matrix form, and then there's an RREF function for it. It's really cool. Yeah, a lot of students don't know like how good they got it with the TI-84. Again, you can solve like simple systems of equations by just graphing them. There's a lot of cool stuff you can do. We dropped a log or two. This one is super easy. Yeah, okay, yeah. So what you know is that pH is equal to negative log of the hydronium or like concentration, hydrogen ion. So if this is 6.5 is equal to the negative log of x, then what you do is you just, first of all, move the negative over. And then do 10 to the. So you get 10 to the minus 6.5. Which, I don't know, that's like 1 times 10 to the minus 6 or some shit. Uh, 10 to the negative 6.5. Yeah, 3.16 times 10 to the minus 7. Yes, good job, Jeff.
My man.
That's correct. Log 10. Yeah, anytime we say log, this is the funny thing. In Mathematica, if you say log, it assumes log is log base E, which to me boggles my mind because, bro, what? We have something even shorter for that. It's called ln. Yeah, we have ln for a reason, exactly, right? But no, I shit you not, dude. Like, if you put in this here, let's go to Wolfram. If I say, like,
ln's log of n.
Yeah, watch this. If I say 6.5 is equal to negative log of x, it'll say, look at this. Assuming log is the natural logarithm. Bro, what? We have ln for that, right? I could do this. Yeah. See, but it still writes it as log. No.
You done messed up, Aaron.
Because log is the natural log. God damn it. That's what ln's for. So you have to say this. I think you have to say, I think you say log 10 is what you say. There you go. If you say log 10, it does it. Wait, did it fucking solve it for me, though? Wait, solve it. There you go. There's the solution. Anyways, yeah. Oh, sensation's gone. Okay, that one's not too bad. Yeah, so you can do that as well. Yeah, you can do those. Those also work as well. Okay, let's see. Determine the density of a sample of oxygen contained in a 4-liter container in STP. Okay. Interesting. Well, I know that 22.4 liters is equal to 1 mole of O2. Density is equal to mass over volume. Right. So, I'm going to get the... This is hilarious. The volume is 4 liters, right? This is too funny. And then the mass, right? Mass is going to equal to 4 over 22.4, because this will give me the number of moles of O2 I have, right? And then I'm going to multiply that by, I think, 32. That's the molar mass of O2. So I'm going to have 4 over 22.4 times 32, all divided by 4. Damn, I have to study for Deagle's MV? Oh no, I know, it's so sad. Right, because this is the number of moles. And then this right here is the molar mass. Driver's license, Department of Motor Vehicles. So this is actually kind of cool because this will cancel with this. It's just 32 over 22.4. What is that? 1.43. So that's going to be 1.43 grams per liter. Which I don't know if they allow this as a... Well, okay. That's the same thing as 1.43 grams per 1,000 centimeters cubed. So you could divide it by 1,000. So you could say this is 1.43 times 10 to the minus 3 grams per centimeter cubed. I think. Yeah, okay, cool. Does that make sense, Equity? Are there any gases denser than water? I actually don't know that. I mean, there are gases definitely denser than air. Denser than water? Ugh, I don't know. That's pretty... I mean, liquids are pretty fucking dense. Yes, 1,000 centimeters is 1 liter. 1,000 centimeter cubed is. And the reason for that, Equity, is that 1 centimeter cubed is equal to 1 ml. And so there's 1,000 mLs in 1 liter. Yeah, hexafluoride. But yeah, it's... Yeah. That's the one that you can inhale and it'll turn your voice into Darth Vader. So you can inhale helium, and helium will make your voice sound like really like squeaky and high. Wait, uranium hexafluoride? I hope not. What? No one should be inhaling that. But
so for the demo here, if you were to inhale helium, your voice would sound really high, and the reason for that is that helium is lighter than air. So the medium in your vocal cavity, sound waves travel faster. And if things travel at a faster speed, they travel at a higher frequency. And that's why your voice sounds higher. If you have something that's heavier than air, then the waves travel slower. And then you get a lower frequency.
Which is why you sound like Darth Vader. Uranium hexafluoride is actually a thing? Well, this says it's a solid. So, it can't be a gas. Why can't you write it as 1.43 grams per liter? No, you totally can. I just don't know if your teacher wants this or if they want this. Like, in physics land, this is not a density. We don't do things in grams per liter. In physics land, we do grams per cubic centimeters. Or really, we do kilograms per meter, but that's for another day. All right, let's do this last one. Then I'm gonna wrap the stream up. We've had a good amount of time here. Okay, let's see. Oxygen gas can be produced by heating potassium chlorate in the presence of a catalyst such as manganese 4 oxide. Yeah, sulfur hexafluoride. Yeah, that's what I thought it was. At the completion of the reaction, 45 mLs of oxygen gas was collected over H2O at atmospheric pressure of that and a laboratory temperature of 22 degrees centigrade. If the vapor pressure of water at 22 degrees Celsius is 2.64 kilopascals, what mass of potassium chlorate was used? Yeah, this is always like the collecting fucking bullshit stuff. Remember how this works. Because you have like the H2O here. And that's like outgassing out, right? And then that has... So pH2O is now equal to 2.64 kPa. But then the atmospheric pressure is 101. It should be 101.3. in a real lab, do you memorize conversions? No, you look everything up, but that's not the point of class. One sec. I can remember, like, I forget if I add that pressure or if I subtract it. It's a partial pressure for sure. But I remember, like, which way we do it. Grams per liter is fine then. Yeah, okay, this is what it is. Okay, got it. All right, so there's a pressure of H2O, right? And there's also this pressure of this O2, which is equal to blank. But then these two pressures together need to add up to P atmosphere, the atmospheric pressure, which is 101.0 kilopascals. Okay, so that tells me that PO2 plus pH2O is equal to P atmosphere. So PO2 is equal to this minus this. So that's going to be 101 minus 2.64 kPa. And so if we do that, 101 minus 2.64, that's going to give me 98.36 kPa. Okay, cool. So that's the pressure of the O2. And then we have the volume, which is equal to, what is that? 0.045 liters. We have the temperature. Temperature is 22 degrees, but gotta remember to put that in Kelvin. So that's 22 plus 273, so that's 295. I believe we're gonna use, what are we gonna use for R? 8.3414 probably. 273.15. How do you school and stay thin? I'm not very thin. This Pornhub, we make millions. Put this on Pornhub, we make millions. I've seen that. People have started putting like math lecture stuff, or like, no, they put like DJ concerts on Pornhub because it won't take them down for copyright. It's fucking hilarious. Okay, so PV equals nRT. That tells me N is equal to PV over RT. Which I think if I'm using this is like liter atmospheres. No, this is liters kPa. Yeah, okay. So I can say that this is equal to 98 point... And let's look at that. One second. Let me go find that. One second. R constant. Food makes you not tired. Too much make you bid. That's true. Okay. I think... oh, here we go. This is what I'm looking for. I always forget which R we're allowed to use. No, honey, it's a constant. My favorite band. Okay, here we go. I always forget which. Okay. All right. If we are using liters, moles, Kelvin, and kPa, we're allowed to use this. If you end up using meters cubed, moles, Kelvin, then you have to convert this to pascals. I always remember it's some weird conversion there. Okay, so this is N is equal to 98.36 times the 0.045 divided by 8.314 times the 295. And so what does that get you? So that times 0.045 divided by 8.314 divided by 295. 0.0018 moles. Cool. Well, if we know this is 0.0018 moles, now I can figure out how much potassium chlorate was used. I can say how many grams of KClO3 is equal to 0.0018 moles of O2, 3 moles O2 to 2 moles KClO3, and then 1 mole KClO3 is what's the molar mass of KClO3? 122.55. Or just say grams. Okay, so now we just do math. We do math. Times 2 times 122.5 equals that. Divided by 3. Should get you 0.147 grams. I think that's correct. I googled mole and it's some type of Mexican sauce.
That's dope.
I low-key love mole. Mole is fucking great, actually. I really do. I like mole. Okay. Cool. Nice. Good job, Equity. Okay, I think that's all the questions for today, so let's close out the stream. All right, thank you, everyone.
That's dope.
For coming to Actual Education Office Hours. Appreciate you guys asking all your questions. Thanks for hanging out with us, learning some math, science, physics, all the fun stuff with us. GG's, yeah, appreciate all the fun question you guys asked. And I like the combinatorics. I like the chemistry. We did chemistry, we did physics, we did probability, we did math, we did everything. We love all stuff here. That's dope.
That's dope.
It definitely was Femvox. Okay, no stream tomorrow because I got to go figure out if I have a job next quarter at some UCLA Town Hall. But I will make an announcement in our Discord. If you haven't joined our Discord, the link's like right there. If I'm streaming later in the week. Otherwise, next stream will be Monday, and that'll be at 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Central, 6 p.m. Eastern. Good luck with keeping my position. I appreciate it. You missed your calling as a chemist. I do like chemistry. Yeah, chemistry's fun. I just don't like all the memorizing. I wouldn't want to like memorize all the organic chemistry shit. Like I don't like memorizing certain reactions and things. Okay, let's see. Who do we want to go raid? Someone's building an 1890 electric light that blinds you. That seems pretty cool. Let's just go check. Let's see. What is this person doing? They're building something, it looks like. Definitely. Okay. Go say hi to these guys. I don't know. Anyways. All right. I hope you guys have a wonderful rest of your week. Enjoy your Wednesday. Enjoy your Tuesday, sorry. And we will see you next time. Peace.
Do I still have any of those leads?